In this video, we're going to take a look at an example of how to construct a confidence interval using the t-distribution. So it says 6 different national brands of chocolate chip cookies were randomly selected at a supermarket. The grams of fat were as followed, and they gave us some sample information. We've got 8, 8, 10, 7, 9, 9. Assume that the underlying distribution is approximately normal. Construct a 95% confidence interval for the average grams of fat per serving. Now, at first glance, this looks like a problem. I'm actually going to jump ahead in my list of steps here. I'm going to jump ahead just to step 2 for a moment here, because it says, hey, we need to verify that the conditions for the central limit theorem are met. And one of those conditions said, hey, we want n greater than or equal to 30. And we actually don't have that here. We've got 1, 2, 3, 4, 5, 6 different brands that we surveyed here. So in this case, our n is equal to 6. That is most certainly not greater than or equal to 30, which seems like a problem right here, except for one sentence which we are saved by, where it says, assume that the underlying distribution is approximately normal. That sentence alone says, hey, the conditions for the central limit theorem are met. We can continue on. There is no extra added stuff that we're going to have to do. So that is very good news for us. So the conditions for the central limit theorem are met. Now, actually, if I look at this problem, I'm going to hop back now to step 1. Step 1 says we want to pick out all of our important information. So the key pieces of information, we said we would want x bar, our sample mean, we would want s, our sample standard deviation, and we want n, which is, of course, our sample size. Well, we've already said n is equal to 6, so that's my sample size right here. But this problem does not explicitly tell us what x bar is and what n is. So that's going to be up to us to go find those pieces of information. Now, I'm going to use the graphing calculator to help me find those. The sample mean would not be too terribly difficult to do by hand, but the standard deviation is a bit tedious and it is kind of a pain. So we're not going to do that by hand. We're going to let our graphing calculator do the heavy lifting here. So I'm going to hop over to my graphing calculator, which, oops, that's not what I wanted. I want to open up my graphing calculator. Let's clear out these ads. I apologize about that. So I'm going to go ahead and start by entering my data. So the way that I do that, remember, I press stats, and then I'm going to choose number 1, edit. And I'm just going to enter the data set that I have right here. Now, if you have some other numbers that are already there from last time, you can clear this list by going up to the top, highlighting L1, press clear, and then press enter, and that'll allow us to start with a fresh, clean slate right here. So we said our data set was 8, and then 8, and then 10, 7, 9, and 9 right here. So we want to make sure that we enter those data values first. And then once we have those, I like to go back to my home screen. So I'm going to press second and then mode right here. And now I'm ready to go find that mean and standard deviation. So I'm going to press stat. We will arrow over once so that we're under calc, and we're going to choose that very first option. It says 1var stats. And if you have a newer calculator, you'll see a menu that looks something like this. We can just go down to calculate and click enter. If you have an older calculator, it'll probably just say 1var stats, and then it's got a blinking cursor. If you just press enter, you're going to see the exact same thing we're going to see right now, which here is our mean. Our mean is x bar is 8.5, and then our standard deviation in this problem is 1.049. I'm going to go around to 3 decimal places just to be safe, but 1.049. So let's hop back and make notes of that. Hop back to my notes here. So we said our mean is 8.5 and our standard deviation was 1.049. So at this point, I have my mean and I have my standard deviation. So that was my first step. We've gathered the correct information. We've already done the second step where we verified that the central limit theorem works because we have that underlying population is normally distributed. So that's good to know. Now we can get to the actual building of the confidence interval. And actually, before I do that, I'm going to have to find my T star. So actually, before I do that, let's pause for a moment and find that. So we said we wanted a 95% confidence interval. So a 95% confidence interval. So remember back to a couple videos ago when we were talking about how to deal with the T distribution. We said, oops, boy, I cannot draw today. There we go. That's a little bit better. We want the proportion in the middle to be our confidence level, which in this case is 0.95. I want to find the two-tail area. So that's just going to be 1 minus our confidence level. So 1 minus 0.95 to end up with 0.05. So our two-tail area is 0.05. One very last thing that I need to know my degrees of freedom. So remember also that my degrees of freedom, we said are n minus 1. So in this case, 6 minus 1, we end up with 5 right there. So we now need to go and find the T star, because that's what we're after here. My T star is going to be a two-tail area of 0.05 with 5 degrees of freedom. So I need to hop over to my tables. We said we had 5 degrees of freedom, which means this is the row that we're looking at. And we have a two-tail area of 0.05, which means we're looking at this column. This is the row we want, and of course the intersection between those two in this case would be 2.57. So my T star in this problem will be 2.57. So let me hop back one last time. My T star is equal to 2.57. Oops, I had it up here. 2.57. Cool. So at this point, I have everything I need. I have X bar, I have my standard deviation, I have N. I'm ready to go and start my calculation then. So just so that I have all this information in front of me, I'm going to copy and paste this. So let's bring this down right here. So I have all of my relevant information right here. First thing that I need to do is I need to find my standard error. So my standard error, we know, is the standard deviation divided by the square root of my sample size n. So my standard deviation in this problem is 1.049 divided by square root of my sample size n is 6. So, okay, I'm going to grab my calculator off to the side over here. 1.049 divided by radical 6. I end up with 0.428. I'm going to round to 3 decimal places for this problem. So we've got our standard error. Next up, I need my margin of error. So my margin of error is simply just T star times the standard error that I found last time. So in this problem, my T star, we said that was our 2.57. So 2.57 times my margin, or excuse me, my standard error, which was what we just found, 0.428. So again, grabbing my calculator, 2.57 times 0.428 gives me, let's see, 1.0999. Now, if I round that to 3 decimal places, that 9 makes this go up. So let's see, that would be the same as 1.100. So just 1.1 here in this case. And then I can now go and build my confidence interval. So my confidence interval, to actually go and build it, I take my point estimate, which is the thing I'm using to estimate my parameter, which in this case my parameter is the population mean. We would like to estimate the confidence interval for the average grams of fat per serving for all chocolate chip cookies. So my point estimate in these types of problems is always X bar plus or minus my margin of error m. So I want to take my X bar, which I have as 8.5. So we have 8.5 plus or minus my margin of error, which we'll just use 1.1. So this is actually, remember, 2 separate calculations. We have 8.5 minus 1.1 and 8.5 plus 1.1. So if I go ahead and do the subtraction, my lower bound is going to be 7.4, and my upper bound 8.5 plus 1.1 is 9.6. So this is what my confidence interval looks like. I have 7.4 to 9.6. And then, of course, the other thing that I want to do with this is I want to write a short little summary of what this says. So this piece right here says, we are 95% confident that and let's make sure that I have this correct. We had the average grams of fat per serving. The average grams of fat per serving and I want to mention my population here. We're talking about all chocolate chip cookies. All chocolate chip cookies. Chocolate chip cookies is between 7.4 and 9.6 grams. So the interpretation should feel very, very similar to the confidence intervals that we did way back when we're talking about proportion. The one key difference, the one thing we want to absolutely make sure we talk about is here, remember, we're talking about averages rather than percentages or proportions. So we're going to want to make sure that we mention that term